from yesterday? So pull out your worksheet from yesterday. Look at the front side. It's the geometric series worksheet. Okay, so if you look at number 8 and number 12, they are not the same. So if you got the same answer for 8 and 12, so number 8 and number 12 appear to be the same, but there's a difference. Do you know what it is, Sadie? There. Okay, Kelsey? I don't think that works. But on this, you're right on the second one, you definitely have to put parentheses. Josh? Good. So here, my sequence is going to be -1, and then we're timesing by 2 every time. So -2, -4, -8. And down here, I start at 1. What's the number out front here? A 1. We're not timesing by -2, we're timesing by 2. We're taking -1 and timesing it by 2. So this could be written -1 comma 2 to the m minus 1. And this one down here would be written 1 comma -2 to the, what is it, n minus 1. So you see that in this top one, that's a bank account that starts $1 in the hole, and you're doubling your debt every time. But down here, we start with $1, and we're multiplying by -2, which is not a bank account at all, because that one's going to bounce back and forth between negatives and positives. So in this one, a sub 1 is -1, and my r value is 2. But down here, a sub 1 is 1, and my r value is -2. So if you got the same answer, you were either not putting parentheses at all on either of them, or you were putting parentheses on both of them. You probably got this one. Well, let's look. Here they are. Hold on. I didn't mean to do that. So the answer for 8 should be -511, and the answer for 12 should be 171. Yeah. So how come the answer for 8 is so much bigger, 511, and the answer for 12 is 171? Aren't we adding up the same numbers? And how does the bouncing back and forth create a lower sum? Some are positive and some are negative. So if you end up with a positive and a negative, they kind of work against each other. Whereas in number 8, they're working together. Okay. So for number 8, that a sub 1 is always the number out front. We don't actually have to plug in 1. We just know it's the number out front. So it's going to be -1 times 1 minus 2 to the 9th over 1 minus 2, which is -1. And the negative ones cancel. No, wait a minute. Did I screw that up? -1. I didn't do something. Oh, yeah, no, that's right. That's right. So the negative ones cancel, and I get 1 minus 2 to the 9th, which is -511. Okay. So for number 10, 4 is my number that goes out front. It's 4 times 1 minus 3 to the 9th over 1 minus 3. So yesterday we were plugging in 1 for a while, and then we realized we didn't need to. So the number out front is actually a sub 1 every time. Okay. So turn the page. We look at number 13. So for number 13, we want to fill out the formula n times 1 minus r to the n over 1 minus r. Do I know n? Yeah, it's given to me. What is it? N is 6. What does n represent? The number of terms. How many terms you're adding up. Okay? So we know n. Do I know r? It's 2. How come? Right. The common ratio is 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So the common ratio is times by 2. And do I know n? Well, I already said I know n. So this gives me everything I need. All I have to do is figure out the common ratio. So 1 times anything is 1. So 1 times 1 minus 2 raised to the 6th over 1 minus 2. Yeah. Oh, not n. I'm sorry. A sub 1. You're right. Ooh, that was scary. It's a sub 1. Thank you. I wrote it right. I just did the formula wrong. So this number goes there. Thank you. So in my calculator, 1 minus 2 to the 6th is negative 63, and I'm going to divide that by negative 1, and I get 63. So the sum of that sequence, or the series, all the way up to n equals 6, is 63. So let's look at the next one. Do I know a sub 1? Yeah, it's the first number. It's 2. Do I know r? Negative 5 times by negative 5. And do I know n? Is 8. So 2 times 1 minus negative 5 to the 8th. And we realized yesterday, can I turn this into a plus? No. But on the bottom, can I turn it into a plus? Yes, because there's no exponent. So 2 times parenthesis 1 minus parenthesis negative 5 to the 8th. Oops. And I'm going to divide that by 1 plus 5. So I'll divide it by 6. How come that's so big? Well, the last term is going to be 2 times negative 5 to the 8th, which is huge. And then you're going to add that to all the other ones. And even though this is alternating between positives and negatives, it's still really big. Okay. So look at number 19. 13 through 18 are really easy. 19 is just a little bit harder. We're figuring out if you take the sequence up to n, so a whole bunch of numbers, and you add them all together, what do they equal? So we talked about this as if you get paid to mow a lawn every week, the sequence tells you how much you get paid on that week. Yeah, S of n equals. Oh, sorry, I'm giving you a big explanation and you don't want it. Yes. How do we find the common ratio if we can't just see it? You always take this number divided by that number. And hopefully it's the same for all of them. So negative 250 divide 50 should be the same as 50 divide negative 10, which is the same as negative 10 divide 2. Because if it doesn't have that pattern, then it's not a geometric sequence. Okay, so number 19. Remember my formula, S of n, for a geometric sequence, for a geometric series, is a sub 1 times 1 minus r to the n over 1 minus r. So for number 19, do I know a sub 1? Yes. Do I know r? Negative 2. Do I know n? No. How do I figure out n? Wait, what's that? Well, if this said s sub n, then I could. But what does a sub n represent? What's the difference between a sub n and s sub n? A sub n is the last number, wherever you stop. S sub n is adding all of them up from the beginning up until a sub n. So if we have a sequence 1, 3, 9, wherever you stop is called a sub n. Wherever that is. Sometimes it's really far in the future, sometimes it's not. If I add all these together, so if I summate those, then that equals, I did it wrong, S sub n. Yes, Sadie. 4 plus 2. It's gonna have something to do with division because we're multiplying every time, right? Well, let's go back to our exponential formula. Okay? We just want to know how far into the future this 1024 occurred. So if I start at $4 and I grow how fast? At -2, which doesn't make sense, but whatever, we'll just do it. And then raised to some value equals what, 1024. But this is a little bit tricky because that is not year 0. Not 6. We're timesing. I don't want to use 4. I want to use -2 because my pattern is 4, -8, 16, -32. But what term is this? That's a sub 1. And this formula only works if that is a sub 0. So if I backtrack, what would this be? -2. So I'm going to put -2 here. And now I just solve for n, which is easy. Right? No. Well, let's try. Let's see what happens. So divide by -2. So 1024 divided by -2 is -512 equals -2 to the n. Well, how do I get an n out of the exponent? I did, and I said guess. Okay? We will learn, you could try the nth root. So if we try the nth root, now we have the nth root of 512 equals -2, and we have the same problem. Now we have an n on the other side, but it's still not by itself. Oh, then you get back to where you started, right? Yeah, we just bounced back. You were just testing me. Okay. Let me show you a way to find the answer every time without actually knowing how to find the answer. So let's look at this equation. And I'm not going to ask you one of these on the test, but I do want you to do these on the problem. Eventually, we're going to learn how to pull that n out of the exponent. And it's so easy to do. You'll hate me for waiting this long. Well, we're not ready. We're not ready. So whenever you have an equation, you can always set it equal to 0 and then find where it crosses the x-axis. So if I subtract 1024 minus 1024, I now have 0 equals negative 2 times negative 2 to the n minus 1024. And then just graph it. Anytime you have an equation with one variable, and I don't care what variable it is, you can always set it equal to 0 and graph it. And sometimes it's not solvable using algebra. There are some equations that algebra will not solve, but you can always graph it. So negative 2 times, make sure you put the second one in parentheses, raised to the x. And we're going to subtract 1024. And I'll graph it, and I might not be able to see the answer. What sort of answer am I expecting? What number, what value am I looking for? I need to know n, right? So n is a positive number. So I'm going to change my window, and I'll go from 0 to 20. And now let's see if I can see it. Not big enough. So I'm going to change it. Let's look from 20 to 30. Something's not right. Did I type it in wrong? Negative 2 times negative 2dx minus 1024. Hang on. Let me do my trick. On second thought, cross off 19 and 20. But 20 would actually work. If you did this method to solve 20, it would work because the graph is visible. But on 19, it's not visible. You could use table to find it. That would work. You could guess. What is n? 9? Okay. And then you could plug it back in. But we won't go there because we don't know how to solve that. But we're getting close. Okay. So now look at number 21. Yeah, don't do 19 and 20. So 20 says, determine the number of terms n in the geometric series. So we're going to kind of have the same sort of problem. So S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. I know S sub n is negative 62 equals a sub 1 is negative 2. R is 5, so 1 minus 5 to the n over 1 minus 5. Now we have the same sort of problem, right? So negative 62. Should we even bother? Let's not bother. So cross off. You can, yeah. It exists. Because nobody's as smart as you. Well, yeah, the other way to do it is so easy. I don't want you to beat your head against something difficult. So go ahead and cross off the rest of those. I can't. If I were to tell you, it wouldn't help. You have to understand how it works. Yes. No. We'll get there. Does it? Huh. Just cross off 21 to 26. Yeah. Next year when I teach this, I'll make sure that I'll teach logarithms before I teach this. Because logarithms really make your life easy. They're so easy to use. But if I were to tell you about them, you'd look at them and you'd be like, what? It wouldn't make any sense. So trust me, you're better off.